examples. Suppose I'm in, say, in two-dimensional space. Okay. I give you, I'd like to first take an example. Let me take an example where I have a vector and twice that vector. So that's two vectors, v and 2v. Are those dependent or independent? Those are dependent for sure, right? There's a combination. One vector is twice the other. One vector is twice as long as the other. So if the word dependent means anything, these should be dependent, and they are. And in fact, I would take two of the first, so here's a vector v, and the other guy is a vector 2v. That's my, so there's a vector v1, and my next vector v2 is 2v1. Of course those are dependent, because two of these first vectors minus the second vector is 0. That's a combination of these two vectors that gives the 0 vector. Okay, that was clear. Suppose I have a vector. Here's another example. It's an easy example. Suppose I have a vector and the other guy is the 0 vector. Suppose I have a vector v1 and v2 is the 0 vector. Then, are those vectors dependent or independent? They're dependent again. You could say, well, this guy is 0 times that one. This one is some combination of those. But let me write it the other way. Let me say, what combination? How many v1s and how many v2s shall I take to get the 0 vector? If v1 is like the vector 2, 1, and v2 is the 0 vector, 0, 0, then I would like to show that some combination of those gives the 0 vector. What shall I take? How many v1s shall I take? 0 of them. Yeah, take no v1s, but how many v2s? So 6. Okay. Or 5. And in other words, the point is, if the 0 vector's in there, if one of these vectors is the 0 vector, independence is dead, right? If one of those vectors is the 0 vector, then I could always include that one and none of the others, and I would get the 0 answer, and I would show dependence. Okay. Now, let me finally draw an example where they will be independent. Suppose that's v1 and that's v2. Those are surely independent, right? Any combination of v1 and v2 will not be 0 except the 0 combination. So those would be independent. But now let me stick in a third vector, v3. Independent or dependent now, those three vectors. So now n is 3 here. I'm in two-dimensional space, whatever, I'm in the plane. I have 3 vectors that I didn't draw so carefully. I didn't even tell you what exactly they were. But what's this answer on dependent or independent? Dependent. Why? How do I know those are dependent? How do I know that some combination of v1, v2, and v3 gives me the 0 vector? I know because of that. That's the key fact that tells me that 3 vectors in the plane have to be dependent. Why is that? What's the connection between the dependence of these 3 vectors and that fact? Okay, so here's the connection. I take the matrix A that has v1 in its first column, v2 in its second column, v3 in its third column. So it's got 3 columns, and v1, I don't know, that looks like about 2, 1 to me. v2 looks like it might be 1, 2. v3 looks like it might be maybe 2, maybe 2.5, minus 1. Okay. Those are my three vectors, and I put them in the columns of A. Now, that matrix A is 2 by 3. It fits this pattern that where we know we've got extra variables, we know we have some free variables, we know that there's some combination, and let me, instead of x's, let me call them C1, C2, and C3, that gives the 0 vector. Sorry that my little bit of art got in the way. Do you see the point? When I have a matrix, I'm interested in whether its columns are dependent or independent. The columns are dependent if there is something in the null space. The columns are dependent because this thing in the null space says that C1 of that plus C2 of that plus C3 of this is 0. So in other words, I can go out some V1, out some more V2, back on V3, and end up 0.